Okay, this will be a video, the third video for derivative of trigonometric functions, where I start discussing that what happened when the trigonometric function is to the power of n, any power of 3. So how are we going to apply this 6 basic formula for differentiating this type of function? So okay, you just have to see what I'm doing here. So we are actually applying chain rule here, right? It's just like, okay, this is just like a sine x everything to the power of 3, right? Sine x to the power of 3. So of course, when we're differentiating this type of function, it's a composite function where the trigo function is up to the power of 3, right? It's inside the power of 3. So we start differentiating. Now we can start differentiating. We apply chain rule or power rule. So dy dx. So you have to deal with the power first, 3. And sine x, right? Sine x. The 3 you have to minus with 1, right? As you're differentiating. So first step. Second step, you will have to, the first step is you bring down the 3, and second step is copy back this thing, you take 3 minus 1. So later, you differentiate the function inside the power. So which is differentiate sine. Differentiate sine, you're getting cos. So you have cos x. So then your answer will be 3 cos x, okay? 3 cos x. This one I can put in front here, and this one you can put as sine square x, right? 3 minus 1 is square. So you have sine square x. So you have 3 cos x sine square x. So let's go for more examples. Okay, this one baby, y equals to cos to the power of 4 x squared plus 1. So it's actually written as y equals to the cos of angle x squared plus 1, everything to the power of 4, right? There is a power here. So when there is a power, you cannot differentiate dy dx straight away, cos become negative sign. Cannot, because there is a power here. So you have to apply the chain rule, deal with the power first. So how was it? So you see the flow. If you don't understand, you replay, and you see that the dy dx. So I have to use the chain rule. So the 4 come down. First step, second step, cos x squared plus 1, salin balik sebiji sama. So and the 4 you minus 1, second step. Third step, look at the angle inside here, right? The angle inside here. Look at the function inside the power, right? First step, 4, right? This whole thing copy back, and 4 minus 1, right? Then later, we look at what is the function inside here, which is cos, right? You want to differentiating the function inside here, differentiating cos. So you see, differentiating cos is negative sign, right? So you have negative sign, not x, but x squared plus 1. For use what is the given angle here. Then later, you have differentiating this cos, become negative sign x squared plus 1. Don't forget to differentiate the angle inside here. So which will be x squared. Differentiating, you will have 2x. So you have complete differentiate. So see the flow. So equals to negative 2 times 4, negative 8. And x sine x squared plus 1. Sine x squared plus 1. And cos x squared plus 1. X squared plus 1 to the power of 4 minus 1, 3. So to the power of 3. So completed, differentiated. Alright. Let's go for more examples so that you can see the flow of applying the chain rule. Alright, let's continue with these examples. So you have y2 sine 2x to the power of 3 plus with tangent 4x plus 1 to the power of 2. So before I differentiating, I rewrite this whole thing to be 2 sine 2x to the power of 3 plus with tangent 4x plus 1, everything to the power of 2, right? So you have 2 sine 2x to the power of 3 plus with tangent 4x plus 1 to the power of 2. This is before you're differentiating. So now you start differentiate with respect to x. So of course there is a power here, right? Without the power you can straight away changing become cos, but now there is a power, so you have to bring down the power by chain rule. So you have 2 times 3, 3 times 2, 6. Salin balik, copy back this whole thing, the 3 minus 1, right? Second step. Third step, differentiate the function inside the bracket, which will be sine. Differentiate sine, you are getting cos. So you will have the cos, you're getting cos, but this angle will follow what here? What is here? 2x, cos 2x. And differentiate the angle. 2x, you will differentiate, you're getting 2. Okay, this is I already complete differentiate for this, right? Followed by plus, differentiating this to the power of 2. There is a power of 2 here, so deal with the power first. So apply chain rule, bring down the power to tangent 4x plus 1. Step 1, bring down the 2. Step 2, salin balik. The 2 you minus 1, right? Then only you look at the inside here, the tangent, differentiating tangent. Differentiating tangent, the third formula will be secant square. Just remember, differentiate tangent is secant square. So 4x plus 1 will be follow. Finally, differentiate the 4x plus 1. So you will have 4, right? So I have complete differentiate everything here. So it's time to rearrange, right? So rearrange your dy dx will be 6, 2, 6, 2, 12, cos 2x, sine 2x to the power of 2. 3 minus 1 is 2, so power of 2, right? 12 plus cos square sine square at 2x plus with 2, 4, 2, 4, 8, right? 2, 4, 8. So, and here you have tangent 4x plus 1, power 1. 2 minus 1 is 1. So, secant square 4x plus 1. Alright. So, I just leave this as the answer for this function here. Okay, let's go for more example. Alright, let's continue with this example. So, you see that there is a square here, right? There is a power of 4 here. So, to differentiate this one, so you rewrite as they are having power. So, they are cotangent 2x minus 1, power of 2. The second square of x, this is an angle inside here. So, it's power of 4, everything. So before differentiating, you have to make it clear that there is a power. So I have to apply chain rule before I apply the basic formula here. So, alright. So we have dy dx, differentiate with respect to x. So 2, step 1, bring down the 2. And the 2, you minus 1, right? So this whole thing, you bring down the 2, and this one you copy back, the 2 minus 1, right? Then only you start looking for what's the formula suitable here as you want to differentiate the inside the bracket here. Differentiate cotangent. Differentiate cotangent, you have negative cosecant square, right? So in another bracket, you write negative cosecant square. So what is this? This will be the original angle here. So 2x minus 1. Okay, not finished yet because you have to differentiate the angles also. So it will become 2, right? So I have done for this part here. Alright, followed by plus. Now I go to differentiate this section here. So there is a power also for this trigonal function. So you bring down the power. And you copy back the bracket here, but the 4 you reduce by 1. Okay, so then differentiating the angles, the function inside here. So the function inside here will be second. Second tangent. So you have second tangent. Just remember, you have second tangent. So you just use back the angle here. So you just square of x, square root of x. But not complete yet. You differentiate second, you're getting second tangent. But you have to differentiate the square root of x separately as well. Multiply, differentiate square root of x. Square root of x is x to the power 1 over 2, right? Differentiating this one is like 1 over 2, differentiating 1 over 2, x, 1 over 2 minus 1, negative 1 over 2. So you have half x, negative 1 over 2 here. So now I have complete differentiate everything completely. So my job now is to just arrange. So this is the most important step here, where you should know how to differentiate, right? So dy dx. So you have, see here, 2 and 2. Negative 2 times 2. So you have negative 4, right? Negative 4. Cotangent 2 minus 1 is 1. So you have 2x minus 1. So then here you have cosecant square 2x minus 1. Plus, go for the other side. So 1 over 2. 1 over 2 and 4. So you have 2, right? This one you have x to the power of negative 2. X to the power of negative 2 is 1 over 2 square root of x. So it means that this is a 1 over square root of x. So you have 2 square root of x. 2 over square root of x. And here you have second. Second, 4 minus 1, you have 3, right? Second to the power of 3. Second to the power of 3. And here second power of 1. So second power of 3 and second power of 1. 3 plus 1, you're getting 4. So second power of 4 square root of x. Second power of 3, second power of 1. So 3 plus 1, 4. So and finally you have tangent square root of x. Complete differentiate. So hope you're getting more understand by using the chain rule for this problem here. Okay, let's go for one more example for you. Alright, let's make the final example as a simple example. As long if you can do this correctly, you are understanding what I'm saying. So as you say that y equals to cosecant, right? Cosecant e to the power of negative x to the power of 5, right? Cosecant e to the power of negative x and to the power of 5. Everything is power of 5. So to do this type of differentiation, you have to make sure that everything is inside that power. So what you're doing here will be you're using the chain rule. 5. Then you have cosecant. You just copy back what is given, right? Copy back, but the 5 you have to reduce 1, right? Reduce by 1. Then after you complete the second step, and you look at the function inside the power. Just don't look at the 5, look at the function here. Differentiate cosecant, right? Differentiate cosecant, you have negative cosecant cotangent. Just write the formula, just follow the formula, negative cosecant cotangent. But what's the angle inside here is depend on what is given. So e power of negative x and e to the power of negative x, right? And now you have differentiating cosecant. You have first you differentiate this one 5, later you differentiate cosecant, right? So finally you differentiate the angle inside here. So differentiate exponent is like salin balik, copy back, differentiate negative x, you have negative. Then you have complete, right? You have complete the differentiation, which will be long, very long, negative, 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 negative. So you have positive, positive 5 e to the power of negative x. 5 e to the power of negative, negative, positive, right? So then you have cosecant 4, right? 5 minus 1, you have 4. So this is power 1, but they are exactly the same thing, right? Cosecant, cosecant e negative x. So 4 plus 1, you have 5. Cosecant e to the power of negative x to the power of 5, right? And you have one more, cotangent e to the power of negative x. So that will be your answer for this question. So hope you replay the video and see more and do practice, right? And eventually you will understand. Alright, see you in the next video.